All right, who wants to listen, talk about AI and learn a little bit more about AI? Artificial intelligence has been a buzz over the last year throughout the DOT. First and foremost, I'm John Ketterling. I'm the Director of Product Development for the DOT. I'll be emceeing this session here. And we have heard a little bit about ChatGPT on the last speaker and how that's been used. How does AI relate to transportation, right? So we got a gentleman that's gracious enough to come all the way to North Dakota from Washington, D.C., David Kuehn. And David serves as the founding program manager for the Federal Highway Administration Exploratory Advanced Research Program. The program focuses on long-term and higher-risk research with the potential for transformational improvements to the transportation system. Through the program, Federal Highway has supported over 20 research projects on artificial intelligence. David has an MPA from the University of Southern California and a BA from the University of California, Irvine. Please help me welcome David.
Well, hello, and thank you. I think it's great that the Department of Transportation invited me here today to speak to both their staff and their many partners on the topic of artificial intelligence. And this is a really broad topic. It's a topic that's taking a lot of time in Washington, D.C. People are talking about artificial intelligence in Department of Transportation and Federal Highway Administration, across government, and certainly more broadly in the public and in the news for the last year and a half. So what I hope to do is come in and ground you a little bit, because we've been looking at artificial intelligence in the programs that I oversee for probably a little over a decade now. And so I think we have a good sense of what's realistic, what's possible, and where it's heading for transportation. So I will just start with a quick introduction to artificial intelligence, spend some time with what Federal Highway Administration has been funding in terms of research. I also want to point out that there is a lot of work going on through cooperative research programs that would be of interest. I want to spend a minute on chatbots, because that's something that actually a lot of states have been using, though it isn't something that we have been funding. And then end up with some cautions and concerns. And I really hope at the end of this, I'm going to set aside some time for questions or discussions or concerns. And of course, I'm here for the rest of the day and tomorrow if people have follow-up questions. So what is artificial intelligence? This is the definition that we use in the federal government. And it really talks about machines behaving like people, rational people at least, and that they can do things in terms of computations or providing answers or information in the way that people can. It's a very broad definition. There are lots of flavors to artificial intelligence, and it has, in this broader definition, existed for some time. So I'm going to talk about some of the work that Federal Highway Administration has been funding. This work on traffic safety actually goes back over a decade. And so one of the things that we looked at is, again, can we use artificial intelligence? And where we started out was looking at computer vision, which is an area of artificial intelligence. And we have lots and lots of image data. Some of the image data is from the car-centric view. So for instance, data that were collected as part of the National SHARP 2 Strategic Highway Research Program, the second one, which had a naturalistic driving study that has over 1 million hours of video. A lot of the video comes from roadsides, from cameras. And then every day there's more and more sources of video data. Now the video data is very hard to deal with because a lot of it is not designed specifically for an experiment. You don't know necessarily the ground truth, and so it takes a lot of effort to prepare the data to do things like create bounding boxes around items of interest and then being able to classify them. So we spent a lot of time looking at how can you use machines to help increase the automation of that, to reduce the effort so you don't have to have dozens of grad students spending hours and hours and hours deciding what color is the traffic signal. If you look in these pictures here, you can usually identify the signal heads, but because of the size of the images, it's very hard to tell what the signal phase is. And of course, if you had a designed experiment, you might have the signal phase and timing information and combine that with the timing of the picture, and then you would know what it is, and then you could help train the machine to identify. But if you're starting with raw data, you need to actually go in there and have humans annotate it. So that's one of the things we're trying to do is improve the speed. And when we started 10 years ago, we were just looking at objects. Can you find a signal head? Where are the vehicles? Is there a vehicle in front of you? Is there a vehicle in the adjoining lanes? Are there pedestrians present? As tools became more sophisticated, trained on more data, we really have been able to increase the types of things that we've been looking at in terms of safety. So we've been moving from object detection to object tracking, from object tracking to being able to actually have machines look at what is the behavior in the picture. So if you look here, more recently, we funded research, and part of the images we're looking at the interactions between electric scooters and vehicles. How do the people who use electric scooters use the roadway? Are they in the lane? Are they on the sidewalk? Are they wearing helmets? Generally not. And that really was helping understand, combined with some actual changes in the roadway markings, some experiments to figure out how do people naturally use the roadways with these micromobility devices. So this is really looking at moving, first you have to be able to identify the object, you have to classify the object, and then you have to have some relational information that the machine is understanding to look at the behavior. But if you're able to do all that, and again, we're doing this after the fact, looking at videos, so you can use lots of computational power, that can give you a really good assessment that can look at how do you develop countermeasures for pedestrians, countermeasures for micromobility, to make sure that you have a safe environment. And we're moving to the point, if you start looking at, for instance, what we're doing with the Small Business Innovation Research Program, that can you take these very computationally intensive algorithms, be able to simplify them, actually put them at the edge, put them in the signal cabinets, and be able to conduct them real time so you can actually use that detection, the tracking, the understanding behavior to influence signal timing. So those are some of the things where we see what we started with 10 years ago, where we were doing things offline with lots of computation, with lots of human support, and moving it more towards faster and automated for the purposes of safety. Another area, again, more recent, is looking at artificial intelligence for traffic reliability. So some of the things that we're trying to do, and a lot of others are doing, is really looking at how quickly can you detect incidents. So for instance, a lot of people use Waze data. Oftentimes, by the time things are reported in Waze, the incident has come and gone, and all you see is the shadow of the incident. Another thing that we're trying to do is look at what are some of the causes of non-recurring congestion, and then also how to use these systems back for traffic system management. So again, you have different levels where you're doing detection, so looking at how many vehicles there are, assessing speed. Some of this is camera data, some of it is radar data, some of it is traffic loops, but you also have mobile source data. So looking at, for instance, Bluetooth or other signals coming from mobile devices. And then how do you integrate this? How do you get a picture of what's going on? And then using separate algorithms to look at how can you use this to predict 5 minutes in the future, 20 minutes in the future, 30 minutes in the future, in order to better predict and understand traffic management. And certainly of interest, for instance, in people in North Dakota, is in some of these we're also integrating not just the traffic data, but the weather data, and try to make some predictions in terms of how that would affect traffic. So you might be able to put some speed warnings out, for instance, on the interstate if there's some weather coming up before you actually have crashes because of the weather. Another big area where we're looking at artificial intelligence, and again, this is something that we've only been doing for the past 3 or 4 years, is for infrastructure. So one of the projects that we funded was with Michigan Technological University. They've been working with the DOT in Michigan for the past 3 winters on winter maintenance. So the first 2 winters, really what they were focusing on is collecting the data, the traffic data, weather data, road temperature data, to understand what is the impact on the road surface. They also are tracking what was the DOT doing in terms of treatment. And so really what they're trying to do is get better automation of collecting and interpreting that data, and then going out and again trying to predict what is a suggested treatment on the roadways. And so they've been working the 3rd winter with Michigan DOT. And again, this isn't all the computer or machine going out. We don't have robots out treating the roads. This is advice to the people in the field conducting the winter maintenance. And these are people that have lots and lots of years of experience. So what we're really trying to do is aid the information they have and not replace the knowledge that they have. And that's really what we're learning from this final year, is what are the best ways to provide expert advice and prompts and be able to work with the differences that the people have in the district offices. We've also been using AI for material selection. So we've been doing a lot of work on supplements to cementitious materials. One of the things that people want to know is if you start using supplements, what's the performance of the material? How is it going to work during construction? How long is it going to last? Are you going to be impacting the life cycle, whether it's for a pavement or a structural element? So we've been working with a number of universities around the country who, again, are taking a lot of data from known supplementary materials that have been added and then used in pavements and roadways and looked at their behavior. And based on that, using artificial intelligence, they can then take an estimate of what would change with slight differences in the mixes, the differences in the chemistry, the differences in approaches. And this is still very much a research question. We've been doing some pilots, but really the question is, how do you actually implement this? Because we're looking at supplementary materials that don't necessarily meet current specifications. So in some ways, we may be able to find classes of materials and work with the asset owners and create new specifications. In other places, it may be that you're not going to see broad use of this until there's more performance-based specifications. But really what we're trying to do is using artificial intelligence and a range of different supplementary materials to give people more choices in how they put their mixes together and really the certainty of how they're going to perform both during construction and during the life cycle. With some of our new projects, we're also looking at pavement condition assessment, which there is a lot of work already taking place in terms of artificial intelligence that looks at the high fidelity photos of the roadway as well as other sensors, and make a prediction of not only what is the condition today, but what is the life cycle of the pavements. And then we've also been looking at some overweight vehicle detection. So a lot of the overweight vehicle detection is looking at image sensors, so image sensors that may be placed on the side of the roadway that could look at the deflection in the structure and say that this vehicle is higher than the rating for that structure. It would also give a sense of being able to do this in places where there are concerns about a specific structure or where there may be seasonal heavy loads, and give better understanding of how much and how often these types of vehicles are going over specific structures. So that's the idea behind this. It's a small business innovation research program. And again, it's supposed to be providing not just research information, but real-time information that the DOT can then go and use to provide better routing for heavy vehicles. So that's some of the areas in our infrastructure. There's a lot more information available in terms of some of the work that we have been doing across exploratory advanced research and other programs. And I just want to make sure that this is someplace you can find this. So besides what Federal Highway has been funding, and a lot of what I've talked about has been both academic research as well as business with small research businesses, I do want to mention and cover a lot of the work that DOTs, North Dakota DOT and other DOTs have been funding through the National Cooperative Highway Research Program. So one of the programs is the IDEA program, which is innovative ideas deserving attention. It works something like small business innovation research in that it's supposed to be work that is close to maturity, that with funding, it could move to something that you could go out and pilot or commercialize in the near future, in sort of 2 to 5 years. And so again, there are a lot of systems lately that have been looking at artificial intelligence applications. Some of them are looking again at pedestrians and collecting information about both pedestrian infrastructure as well as pedestrian use. So for instance, one thing, if you're looking at where are your sidewalks, where do you have curb cuts, a lot of that information is missing. A lot of information is hard to combine between local agencies and DOTs. And so as you try to look at what is the whole system for pedestrian networks, a lot of people are using artificial intelligence. And again, the machine makes it easier. You still need a human to verify a lot of the data, but it may be 10% of the work as opposed to 100% of the work of doing it manually. Or maybe someday it will be 2% of the work. There's also, again, work through NCHRP looking at systems management and what are measures that transportation management centers can use to avoid or reduce congestion, maintain mobility. So this may be for known events, whether it's a special event or a weather event coming in, or it may be reacting to incidents. Again, NCHRP is also looking at how to use artificial intelligence to better understand safety concerns, and then what are the types of countermeasures that you could put in place to reduce and improve the safety in those locations. And then finally, again, there's also other infrastructure applications looking at pavement management. So besides the work that we've been doing at Federal Highway Administration, which again tends to be a little earlier stage or focused on the small business, the NCHRP tends to be work that is closer to being ready, that DOT should be able to use in the next couple of years. So moving from something that I knew a lot about before I came here one of the things I wanted to look at was specifically chatbots, because this has become an area of a lot of discussion. And there are a couple of things about chatbots that have made them very popular, particularly in the press. So one of the things is they're easy to interact with. They're visible, you see them, whether you are texting or speaking. They also have become much more available and much stronger in the types of applications that you can apply them to. So chatbots have existed for a number of years. I think if anyone has made a reservation for a plane or for a hotel, you've interacted with a chatbot. If you look at, for instance, autocomplete when you're using email, you're looking at sort of the same machine intelligence that is used for chatbots. They're trying to figure out what's the next thing it should say, whether it's a word or a phrase, responding to what you inputted as a human. But in the last couple of years, there are now chatbot systems that have trained on so much data that they not only have to be available for what they're designed to do, because before chatbots were very narrow. So if you have a reservation, you know you're looking for like maybe a small range of responses. For instance, I want to get a ticket, I have a problem with my ticket, I want a refund, something like that. So it can say, is it one of these narrow responses? Now you can take these algorithms that have been trained on very, very large sets of data and try them on all sorts of novel things. And for the most part, they work reasonably well. But one of the key things for government use of chatbots is that you want to make sure they don't give out bad information. And so what you need to do is take those generally trained algorithms and train them specifically on information you have. So there are a couple of areas where a lot of states are using chatbots. A very common example is Department of Motor Vehicles. A lot of states now have chatbots to assist people so they can get information faster from Department of Motor Vehicles. Another area that some states have used chatbots is the use within the DOT. So if employees have questions, rather than having to search or type in a search to look for something that isn't an employee manual, they can use a chatbot that's been trained with all the internal documents. So if you just train on your internal documents, you may not get the best document, but you're not going to get something that's completely fictitious or wrong or a document that someone made up. So this is the sort of controls in developing chatbots. But this is an area that a lot of government agencies are now starting to use to really help increase customer service, increase employee responsiveness, and make it easier to find information. And these certainly are getting much better and easier to design than they were 3 years ago or 5 years ago. So I did want to mention that. We're not funding any research on it. I didn't see any cooperative highway program research on chatbots, but I definitely wanted to mention it because there are so many states that are using these. So let me go into some challenges, because certainly we funded a lot of artificial intelligence work. I'm aware of other work that is taking place in the transportation area, but much of what I'm doing is in the research realm or in very controlled pilots. It's not out there for public consumption or for broad use across DOTs and their partners. So one of the key challenges that I think everyone is concerned about with government use of artificial intelligence is one, trust. Is information that I'm sharing, for instance, going to stay within the system and not be shared with others? And how reasonable are these systems? How reliable are they? So one of the things with a lot of the types of artificial intelligence that are being used now is they're based on very, very large data sets. and they are statistical. So they're giving you sort of the most likely scenario. It isn't 100%. You can set the level of certainty you want. How many false positives, how many false negatives? 99%, 95%. And you can make that reliability visible, both to you, to the people who are using the systems. And to some extent, you can also give that reliability to the public who's seeing the system. You could actually have the system say, there's a very high certainty of this. Or it could say, well, this is what we predict, but it isn't a strong certainty. And here is maybe the next thing we predict. But there's a lot of difficulty being able to explain the reliability of these systems. And of course, many of these systems that we've been working with in terms of, for instance, looking at safety data, looking at weather data or pavement data, still have a human in the loop. They're just giving you the best suggestion. But as these systems become more powerful, as they move to the edge, if, for instance, you're using them to control signal phase and timing, you're not going to have a human in the loop. In which case, you want to have a very high level of reliability, and at the same time, you want to know what your failure functions are. So you need to know, is the system behaving the way that it's designed? If it's not behaving the way the system's designed, then what is the fallback? There's lots of issues around this in terms of vehicle automation, but that's not what I'm working on. I don't think that's what many of you are working on. Really, I'm looking more from the roadside. And so again, a lot of these applications, you still have a human making the decision, you're just getting better advice. And where they are moving to the edge, you really need to be able to test the range of situations that they're operating in, and if they're operating in an environment where they're not designed. So for instance, if you're using computer vision and it's not designed to work in a blizzard, then you need to be able to say, what's my fallback? How does the system work when you have that weather condition? So the second challenge I started touching on with trust, and that's the issue of privacy. So a lot of people have concern because artificial intelligence can identify things and share them, and it doesn't know that it shouldn't share them. So for instance, when people put information in, you need to have a secure system. But even if you take information where one point of information wouldn't tell you who the person is, you can take several pieces of information and combine them and say, hey, now I can identify who that person might be. So for instance, if you use location data from a mobile device, or if you use location data from some vehicle system, telematics system, you know where the trips start and end. If you start looking at those trip patterns and know exactly where they start and end, and the stops they make, you may learn things about people that they would rather keep private. So one of the things is understanding what those privacy issues are, and in some cases, not collecting pieces of the data that you don't need to support the privacy. Certainly with image data, a lot of issues because you have face data, you have other defining features that people might have, like a name tag. On vehicles, you have a license plate, or you may have other things that would define and provide information about who the occupants are. So these are all things that you need to look at when you're developing these systems. You need to consider the privacy and then look at the trade-offs. So you're never going to have perfect privacy, but on the other hand, if the purpose of these systems is to improve safety, preserve lives, improve mobility, keep the economy moving, then you have to say, what's a reasonable controls you can have to maintain privacy? The final thing I wanted to mention in terms of challenges is equity and bias. So as I said, when I went back and talked about the image data, that it's very hard to collect image data that shows a wide range of circumstances. Maybe a little bit easier with signal heads. If you look at signal heads, you know there's only so many options you have. Is it red? Is it yellow? Is it green? Do you have a turn arrow? Are you in one of those states where the signal heads have a different orientation? And you can actually look and see what is the distribution of those data, and so is your algorithm working correctly? But if you look at human behavior, if you look at people, there's a much greater variety of what might be out there. And so, for instance, if you have, for instance, signal systems that are looking at pedestrians, it detects a pedestrian, it is predicting the pedestrian path, it's controlling signal phase and timing. Yet, it's only looked at people who are able-bodied. It hasn't looked at people, for instance, in a wheelchair, or someone with a walker, or someone who's using a white cane. Then do you really know that system's going to be working for those people? That's a bias issue. So one of the things that we need to make sure is when we're looking at the data, is it reflective of the people who are actually out there using your systems, the vehicles that are actually out there? So for instance, if you train, for instance, AI on passenger vehicles, you may have a piece of farm equipment. It doesn't know what it is. It doesn't know how to classify it. And that may or may not be an issue. So it really depends on the design of the system, but part of that is looking at where you are and what's the potential for bias, and building that into the development of the system, and then checking, because one of the things is that these systems and what they serve can change over time. So you need to go back and say, is the data distribution still the same 5 years from now, or have there been changes? So, what are some things that you can do to really make yourself ready for considering and applying artificial intelligence in your systems? Two key things is you need to have a data-ready organization. AI at this point is really, really dependent on being able to have access to your data. And so if you don't have good understanding of what data you have, if you don't have the ability to integrate data between different programs or districts, that's really going to limit how well you can apply AI solutions. The second piece is the workforce. So on one level of the workforce, some of the people I work with, some of the people at the universities who are actually developing the algorithms, but a lot of the workforce are not going to be developing the algorithms. A lot of the workforce are going to be using the algorithms in their jobs or getting expert advice from these AI systems and interacting with a machine or a computer. And you also need to prepare that part of the workforce so they understand how the system works. Not the details of how it works, but being able to understand, is it giving correct answers? Is it working within its design, or is it working outside of its design? You don't want people over-relying on the system, but you want them to be able to take the advice if it's good advice, and to be able to take feedback, so if it's not giving a good advice, you can go back to the people who developed it and said, hey, something's not working, there's some change in the data distribution, there's some change in the weighting of the algorithm, and it's not working very well. The other thing that we've been doing is we're starting to pilot risk assessments. So the National Institutes of Standard Technology created a risk framework for artificial intelligence, which is great. It's a framework. They're going to tell you it's not specific to industries. So one of the things that we're starting to do at Federal Highway Administration is how do we narrow those questions down for transportation, and often for specific areas of transportation, for safety applications versus infrastructure applications versus, let's say, internal applications. So as we pilot these risk assessments, we're definitely going to share what we learn, and we hope as other agencies across the country do this as well, they'll share what they learn, so we can better understand where should we be concerned about these systems, and where do we really have a reasonable certainty of these systems. The other things we're working on is trying to develop some privacy tools. So there are methods to try to help preserve privacy in these data. For instance, we worked on some methods for being able to put an avatar on someone's face. So for instance, you can still get the facial behavior. And this is, for instance, data of drivers interacting with the environment. And then we can share that data because you don't recognize who the person is, but you can still see which way the face is looking, what their response is, if their mouth is open, if they're talking on the phone, that sort of thing. So those are some types of privacy tools you can design. And then also, we're looking at what are some methods for testing bias. Because we understand the concept of bias, but there isn't an easy mechanism for saying, are there bias in your data? And so again, as we learn more about what are some ways to test bias, whether it's in image data or in safety information, we want to go out and share that so the industry can be able to start using and implementing those. So with that, I think I have about 10 minutes left. And so one of the things that really made me excited to come here is again, I spend a lot of time talking about artificial intelligence with other people in Washington, D.C., and with academics, which gives me a good sense of some issues, but not of other issues. So I'm hoping that some people here have some questions or concerns or something that they've seen that they'd like to bring up, so I can bring that back when I talk to others in the federal government, so when I can talk to people who are the academics that we've been funding. So I believe that there's someone with a microphone that could come around.
If they have a question, they should raise their hand and we'll get a mic to them.
Okay. So any questions out there? And I'm sorry, if you could really raise your hand high, because the lights are a little bit in my eyes and I can't see. Oh, yep, there's a big, yep, thank you. That's good hand raise over there.
Could you speak to maybe the opportunities of the technology companies that are in the AI atmosphere or sphere compared to federal government and opportunities to collaborate on things, or is it each of these are going at their own different paths forward?
Yeah, so there are a lot of both large and small technology companies that are looking at the government sector. I have to say that a lot of the large companies are not necessarily looking at transportation first, though some of them are. A lot of them are looking at other areas of government because transportation, doesn't get you the returns that some tech companies are looking for. A lot of small companies, so as I said, one of the programs that I oversee is the Small Business Innovation Research Program. So there are a lot of small companies that are looking at leveraging work in AI assessment. A lot of those are looking at computer vision or other sorts of signal analysis. I think the difficulty they have is they maybe don't have a lot of knowledge in the industry. Or if they do, they only maybe have information from working with one local agency. So a lot of these are starting to break in by finding clients in the local agencies, but aren't quite sure how to work with departments of transportation. Or if they work in this state, how do they get to meet people in other DOTs? So it's sort of the opposite issue of the very large corporations that have been doing sort of business to government for a long time and have worked with a number of different states and their IT departments. But there definitely is a very strong commercial presence, and I think that's really what we want to build, is a strong commercial presence that, from what we're working on, is we're trying to do the foundational work and then let business be able to develop it and provide that. And then, of course, some of this, I think some DOTs are going to be able to manage internally for some of these applications. But in other cases, it would make more sense for someone in a business case, a vendor, to be able to provide that across multiple DOTs rather than every DOT or every local agency creating their own system. I see a hand over here. Thank you.
Simple one for you. Which state DOT would you say is kind of the leader in AI right now that we could look as for like a peer?
What state DOT is?
Kind of a leader in AI right now, in your opinion?
Well, that's an interesting question. You know, different states certainly are leading in different areas, and so. You know, I can't say across the board. Some are looking more in some types of applications versus another. So, you know, one of the things, and again, it's so a little bit biased because it's my interactions with state DOTs. I think Texas DOT, again, it's a large DOT. They have a large research unit, and they've been looking at a lot of different applications. They also have a lot of places where they could deploy it because they have a lot of districts. They also have a tech base in Austin, so I think that might support them. We certainly, some of the people we've been working with have been working with MassDOT around traffic operations, and also Maryland State Highway Administration around traffic operations, also Caltrans. So areas with a lot of traffic operations. DelDOT actually has been applying AI and upgrading it in their traffic management center. Small state, but a lot of traffic because I-95 goes through it. And they've been doing that for 5 or 6 years. So those are some examples specifically in traffic operations. As I mentioned, Michigan DOT has been working on the winter maintenance. And they also have been looking at you know, some other types of applications. So again, it depends. You know, if you're looking at peer states, I could try to think of some other states that are, let's say, less urban and have large networks that have been investigating AI. But again, I haven't done a scan. I don't have a comprehensive knowledge, and I think the NCHRP reports probably are a great place to look and see whether there's some peer states that are recognized in those reports. I think I have time for one more, maybe two. Final question? Oh, I see one up front here. Thank you. Yeah, I'm sorry. It's really hard to.
No problem. My name is Tatiana Fedorenko with Ulteg. I wanted to ask, as we head into AI integrating more and more with our industry, what are the considerations, in addition to what you mentioned as far as using avatars for faces, that we need to be considering as far as ethics and the use of AI in the long term?
Yeah, so I think one of the key things is I come from a public sector perspective, and with that, I think we have a very high level of obligation in terms of the fair and responsible use. So, for instance, again, looking at some of these very large models that are now available, you may have heard some concerns that in their training, they captured material that they didn't have rights to use. So for instance, major newspapers, major groups that hold lots of image data are going through a legal process trying to get compensated, or which is really all they can do, because at this point it would be very hard to unlearn the training in the models. So from a government perspective, I'm very concerned about using models that have been trained on data that they didn't acquire in a legal manner. There are other large models, not as large, that have been more careful about how they've collected those data. One of the things is, if you look at the business side, I haven't seen the same level of concern, and I don't think they have the same level of oversight. Obviously, large businesses have shareholders, but I don't think shareholders' first concern is, are the algorithms you're using created in a way that is fair and responsible? So there's going to be some tensions between the public use and the private development of these algorithms. And so I think you need to be very clear from the government side saying these are our concerns. And your concerns may differ. It really depends on what state you're in, what communities you're in, and really going out and saying, you know, what sort of concerns do you have? Are you concerned about these privacy issues? Are you concerned about the control issues, the reliability issues? And then make sure that you communicate that. And then the difficult thing is then how do you actually build that, if you're working with the private sector, into your procurement? So that's actually a condition of what you're getting from the system. So that's a tough question. I think I'll end there, but there's lots of opportunities just as government, state government, federal government, local government, and the partners that work with government. I just want to caution that, you know, we want to take advantage of these opportunities, but at the same time, we want to make sure that we're serving the public in the best interest of the public. So thank you.